In the frozen skies above Bavaria during the final days of the Second World War, a revolutionary aircraft emerged that would rewrite the boundaries of piston engine aviation. The WW2 335 Pfeil, meaning arrow in German, stood as the fastest propeller-driven fighter to fly in combat during World War II, a mechanical marvel that arrived too late to alter history, but early enough to demonstrate what might have been. April 1945. French ace Pierre Clostermann led his flight of 4 Hawker Tempests from No. 3 Squadron across northern Germany, scanning the landscape for targets. The war was entering its final weeks, and Allied air superiority was absolute. Then something caught their attention, a lone aircraft moving at extraordinary speed barely above the treetops. The silhouette was unlike anything they had encountered. Clostermann's Tempests, among the fastest piston fighters in Allied service, gave chase. Despite pushing their Napier Sabre engines to maximum power, the German aircraft effortlessly pulled away, disappearing into the distance. Back at their base, Clostermann and his pilots spent nearly an hour debating what they had witnessed. They had just encountered Germany's last technological gamble, an aircraft that could outrun virtually everything in the sky. The story begins not in wartime desperation, but in methodical German engineering innovation decades earlier. After the Great War ended in 1918, the Treaty of Versailles imposed severe restrictions on German military aviation. Forbidden from developing combat aircraft within their borders, German military strategists secretly collaborated with the Soviet Union, establishing clandestine training facilities and development programs far from Western scrutiny. This hidden partnership allowed German engineers to continue advancing aviation technology throughout the 1920s and 30s, laying groundwork that would bear fruit in the next war. Among these engineers was Claudius Dornier, whose career had begun before the First World War designing massive metal flying boats. His innovative spirit led him to explore unconventional engine configurations that might solve fundamental problems in aircraft design. Traditional twin-engine fighters mounted their power plants on the wings, creating substantial aerodynamic drag and asymmetric thrust problems if one engine failed. In 1937, Dornier patented a revolutionary solution, the push-pull engine layout. This configuration placed one engine in the aircraft's nose, pulling the plane forward, and another in the fuselage tail, pushing from behind. The design offered twin-engine power with single-engine aerodynamics, combining strength with minimal drag. The concept remained theoretical until Germany's military situation grew increasingly desperate. By 1943, the Luftwaffe faced overwhelming Allied bomber formations protected by long-range fighters. German interceptors needed speed above all else, speed to reach altitude quickly, speed to catch bombers before they released their payloads, speed to escape pursuing escorts. The Air Ministry issued requirements for a Schnell bomber, a fast bomber capable of penetrating enemy defences through sheer velocity. Dornier submitted his P-231 design, built around his patented push-pull configuration. The prototype Do 335 Vis-1 completed its maiden flight in September 1943 at Oberpfaffenhofen, revealing performance that exceeded expectations. Test pilots reported speeds approaching 763 km per hour, faster than any operational piston fighter in existence. The design featured 2 Daimler-Benz DB603 V12 engines, each generating approximately 1,750 horsepower. These massive inverted V12 power plants displaced 44.5 litres and weighed 910 kilograms apiece, representing the pinnacle of German piston engine development. The aircraft's specifications told a story of engineering ambition bordering on audacity. With both engines operating, the Pfeil could reach maximum speeds of 763 km per hour at altitude, faster than the American P-51 Mustang, the British Spitfire, or any other operational Allied fighter. Even with one engine failed, the aircraft could maintain 350 km per hour, sufficient to return home safely. Its rate of climb reached 530 meters per minute, allowing rapid interception of high-altitude bombers. The service ceiling extended to 11,400 meters, putting it above most bomber formations. Armament reflected the aircraft's multiple-role design. A single 30mm Mk103 cannon fired through the front propeller hub, its shells powerful enough to destroy heavy bombers with a few hits. Two 15mm MG151 cannons mounted in the nose provided additional firepower. The internal bomb bay could carry 500 kilograms of ordnance, while wing hardpoints accommodated additional bombs or external fuel tanks, This combination made the Do-335 equally effective as interceptor, fighter-bomber, or reconnaissance platform. The push-pull configuration solved problems that plagued conventional twin-engine fighters. When a traditional aircraft like the Messerschmitt Bf-110 lost an engine, asymmetric thrust created dangerous yawing that required immediate pilot correction. Many pilots died when they couldn't compensate quickly enough. The Do-335's centerline thrust eliminated this hazard entirely. Both engines operated along the fuselage axis, meaning single-engine failure produced no asymmetric forces. Pilots could continue flying normally on one power plant without fighting for control. The inline engine arrangement also delivered superior aerodynamics. Wing-mounted engines created substantial drag from their nacelles, cooling systems, and disrupted airflow. The Do-335's engines nestled within the fuselage, minimizing frontal area and allowing clean airflow over the wings. This translated directly into higher speeds and better fuel efficiency. Wind tunnel testing revealed the design produced 40% less drag than equivalent wing-mounted configurations. Yet revolutionary engineering created revolutionary problems. The aircraft's sheer size and weight presented constant challenges. At 9,600 kilograms fully loaded, the Fiel weighed as much as medium bombers. Its tricycle landing gear, advanced for the era, buckled repeatedly under this mass. Early test flights revealed landing gear failures that could have killed pilots. Engineers strengthened the struts repeatedly, but the problem never fully disappeared. Ground crews learned to approach landings cautiously, knowing each touchdown stressed components to their limits. The rear engine created persistent overheating issues. Buried deep in the fuselage with limited cooling airflow, the DB603 regularly exceeded safe operating temperatures. Dornier engineers installed elaborate cooling systems with radiators and ducting, but hot weather operations remained problematic. Test pilots reported temperature gauge needles climbing into red zones during extended combat power settings. Several prototypes suffered engine fires that forced emergency landings. Pilot visibility suffered from the long nose and bulky fuselage. Unlike agile single-engine fighters, where pilots enjoyed excellent sightlines in all directions, Do-335 aviators sat far back with substantial aircraft ahead blocking their view. Formation flying became challenging. Ground operations required extreme caution since pilots couldn't see directly ahead or below. This limitation would have proven dangerous in combat where spotting enemy fighters meant survival. The most innovative and dangerous feature was the emergency escape system. Traditional aircraft allowed pilots to simply roll inverted and drop clear. The Do-335's rear propeller made this impossible. Bailing out meant certain death as the spinning blades would slice through anyone who jumped. Dornier's solution was dramatic. The aircraft featured one of the first operational ejection seats in aviation history. When pilots pulled the ejection handles, explosive bolts fired simultaneously, jettisoning the rear propeller and destroying the vertical stabilizer. Only then could the seat rockets fire, blasting the pilot clear of the disintegrating aircraft. This system was tested successfully, but pilots understandably viewed ejecting as a last desperate measure. Test pilots who flew the Fiel reported mixed impressions. The raw speed was intoxicating, unlike anything they had experienced. Accelerating to maximum velocity created sensations comparable to early jet aircraft. The controls responded smoothly at high speeds where other fighters became heavy and sluggish. Roll rate was excellent for such a large aircraft, allowing rapid evasive maneuvers. These characteristics made it a superb interceptor and bomber destroyer. However, low-speed handling was treacherous. The heavy wing loading required high landing speeds that left little margin for error. Stall characteristics were abrupt and unforgiving. Unlike lighter fighters that provided plenty of warning before stalling, the Do-335 could drop a wing suddenly, spinning before pilots could react. Several test pilots died in low-altitude stalls during landing approaches. Combat operations would have required extensively trained aviators, capable of handling the aircraft's demanding characteristics. By mid-1944, the strategic situation had deteriorated beyond recovery. Allied armies were advancing from east and west. Bombing campaigns had shattered German industrial capacity. Fuel shortages grounded even operational aircraft. The Air Ministry nevertheless ordered the Do-335 into production, desperate for any advantage that might stem the tide. Dornier's factories at Oberpfaffenhofen began assembling pre-production aircraft designated A0, followed by production A1 models. Production proceeded agonizingly slowly. The complex push-pull design required specialized tooling and skilled labor, both increasingly scarce. Allied bombing repeatedly disrupted component deliveries. Engine production couldn't keep pace with airframe assembly. Many completed aircraft sat awaiting power plants that never arrived. Between September 1943 and April 1945, Dornier completed approximately 38 Do-335 aircraft of all variants, including prototypes, pre-production models, production fighters, and two-seat trainers. Different sources cite varying numbers ranging from 35 to 48 total aircraft, reflecting the chaos of final production months. The first operational units received their aircraft in January 1945. Erprobungskommando 335, the evaluation command, began training pilots at Rechlin and Oberpfaffenhofen. Plans called for deploying the Pfeil as a high-speed reconnaissance aircraft and fast bomber, roles that emphasized its speed advantage while avoiding dogfights where its size and weight became liabilities. Several aircraft were assigned to operational squadrons, but no confirmed combat actions occurred beyond the Klostermann encounter. That April 1945 meeting between French Tempests and the German Pfeil represented the aircraft's sole documented combat encounter. Klostermann's detailed account in his memoir, The Big Show, described the incident vividly. His flight was patrolling at low altitude when the Do-335 appeared, flying at maximum speed barely above the trees. The German pilot likely was conducting a training flight or ferry mission when he spotted the British fighters. Recognizing danger, he reversed course and applied full throttle. Klostermann, one of France's leading aces with extensive combat experience, immediately recognized the threat. His Hawker Tempest was among the fastest Piston fighters in Allied service, capable of 473 miles per hour at altitude. Yet the German aircraft pulled away effortlessly, opening the gap with every second. One of Klostermann's pilots pursued briefly before abandoning the chase as futile. The encounter lasted perhaps 2 minutes, but its implications were clear. Germany had developed an aircraft that Allied fighters simply could not catch in level flight. The significance extended beyond that single incident. Had the Do-335 entered service in 1943 instead of 1945, the air war's trajectory might have shifted. High-speed reconnaissance aircraft that could photograph targets with impunity. Fast bombers striking Allied positions and escaping before fighters could intercept. Bomber destroyers climbing rapidly to altitude, making single devastating passes and diving away before escorts could respond. The tactical possibilities were substantial, yet the reality was that war's outcome was determined not by individual aircraft performance, but by industrial capacity and strategic resources. By January 1945, when the first Do-335s entered service, Germany was collapsing. Fuel shortages were so severe that many aircraft never flew. Pilot training had degraded to dangerous levels as instructors died and flight hours were cut. The entire military infrastructure was disintegrating under relentless Allied pressure. No amount of technological sophistication could reverse these fundamental disadvantages. American forces captured Oberpfaffenhofen on April 22, 1945. Watson's Whizzers, the specialized intelligence unit tasked with securing German aviation technology, immediately took control of all Do-335 aircraft at the facility. The teams, led by Colonel Harold Watson, had lists of priority targets, including jet fighters, rocket interceptors, and the mysterious push-pull fighter they had heard rumors about. Finding several complete Pfeil aircraft was a significant intelligence coup. The captured aircraft presented immediate challenges. Allied bombing had cratered Oberpfaffenhofen's runways, making takeoffs impossible with full fuel loads. Engineers studied the problem and determined that a short ferry flight to Oberweisenfeld's grass runway was necessary. Dornier's civilian test pilot Hans Padel, who had flown the Pfeil throughout its development, agreed to fly one aircraft to the undamaged field. The American officers were skeptical, wondering if he planned to defect to neutral Switzerland. Padel assured them he would comply. On the appointed day, Padel climbed into Do-335 work number 240102 and started both engines. American P-51. Mustang fighters took positions as escorts, ready to shoot him down if he deviated from the planned route. Padel advanced the throttles and lifted off smoothly. What happened next entered aviation legend. The German test pilot, intimately familiar with his aircraft's capabilities, opened both throttles to maximum continuous power. The Pfeil accelerated rapidly, climbing and pulling away from the pursuing Mustangs. Within minutes, Padel arrived at Oberweissenfeld 45 minutes ahead of his escorts, who found him calmly waiting when they finally caught up. It was a final demonstration of the aircraft's extraordinary performance. 2 Do-335s were selected for shipment to the United States for detailed evaluation. Aircraft FE-1012 was assigned to Freeman Field in Indiana for Army Air Forces testing. Work number 2, 401. 02, designated FE-501, was allocated to the Navy. Both aircraft were carefully disassembled and loaded aboard HMS Reaper, an escort carrier converted for ferrying captured German aircraft across the Atlantic. The Navy aircraft arrived at Patuxent River Naval Air Station in Maryland in December 1945. Test pilots spent the next 3 years conducting comprehensive evaluations. Their reports confirmed the performance claims. The Pfeil was indeed the fastest piston fighter they had tested, exceeding 470 miles per hour in level flight. Acceleration was impressive, handling at speed was stable, and range was adequate. However, they also documented the landing gear weaknesses, overheating problems, and demanding low-speed characteristics. The overall assessment was that the Do-335 represented brilliant engineering applied too late to matter. By 1948, testing was complete. The aircraft sat outside at Norfolk Naval Air Station for the next 26 years, slowly deteriorating in the elements. Paint faded, metal corroded, systems degraded. It represented a forgotten footnote from a war already receding into history. In 1974, someone at the Smithsonian Institution remembered the aircraft and arranged its transfer to the National Air and Space Museum's storage facility at Silver Hill, Maryland. Dornier GmbH, rebuilt as a civilian aircraft manufacturer in post-war Germany, learned that the only surviving example of their most advanced fighter was deteriorating in storage. Company executives contacted the Smithsonian with an extraordinary offer. They would restore the aircraft to museum quality at their own expense if it could be returned to Germany temporarily. The Smithsonian agreed, and in 1974, Werk number 240102 was flown via cargo aircraft back to Oberpfaffenhofen, returning to the factory where it had been built 30 years earlier. The restoration team included several engineers and technicians who had originally constructed the aircraft in 1944. Now elderly men, they approached the project with mixture of nostalgia and professional pride. Disassembling the Pfeil revealed an alarming discovery. The explosive bolts designed to jettison the tail section during emergency ejections were still live after 3 decades. Watson's team in 1945 had accidentally triggered these bolts on another Do-335, destroying it completely. The restoration team very carefully removed and disarmed the charges before proceeding. Over 12 months, the workers meticulously restored every system. Corroded metal was repaired or replaced. Control surfaces were rebuilt. The engines were disassembled, inspected and preserved. Paint was carefully matched to original specifications. By 1975, the aircraft looked exactly as it had rolling off the assembly line in October 1944. The restoration was unveiled at an air show in Hanover, where it attracted massive crowds. German aviation enthusiasts marvelled at seeing this piece of their technological heritage preserved. The swastika markings visible during initial restoration were removed to comply with German laws prohibiting Nazi symbols. Following the air show, the Pfeil was exhibited at the Deutsches Museum in Munich for nearly a decade. In 1986, it returned to the United States and was placed back in storage, pending construction of adequate display facilities. Finally, with the opening of the Smithsonian's Stephen F. Udvar-Hazy Center near Dulles International Airport, the Do-335 found its permanent home. Today, it hangs in the museum's main hall, one of the centerpiece aircraft representing the pinnacle of piston engine fighter development. Claudius Dornier did not live to see his creation preserved for future generations. He continued working in aviation throughout the post-war decades, founding Dornier GmbH and developing successful civilian aircraft. His contributions to aerospace engineering earned widespread recognition. In 1959, the German Society for Aeronautics and Astronautics awarded him the Ludwig Prantl Ring for outstanding contributions to aerospace engineering. This honour acknowledged not just the Do-335, but his lifetime of innovation, spanning flying boats, bombers, and revolutionary designs. In 1987, 2 years after the Fiel's return to American display, Claudius Dornier received his final accolade. He was posthumously inducted into the International Air and Space Hall of Fame at the San Diego Air and Space Museum. The honour recognised his fundamental contributions to aviation technology, placing him alongside the Wright brothers, Charles Lindbergh, and other giants of flight. His push-pull engine configuration, though never achieving widespread operational use, demonstrated innovative thinking that influenced subsequent aircraft designs. The Do-335's legacy extends beyond its limited production and minimal combat service. It represented the culmination of piston engine fighter development, pushing performance boundaries to their absolute limits. Subsequent aircraft pursuing higher speeds would require jet propulsion, fundamentally different technology that rendered piston engines obsolete for frontline fighters. In this sense, the Fiel marked an ending point, the final evolution of a technology that had dominated aviation for 4 decades. The aircraft also demonstrated the limitations of technological superiority, divorced from strategic reality. Germany developed numerous advanced weapons in the war's final years, including jet fighters, rocket interceptors, guided missiles, and advanced submarines. Yet none could overcome fundamental disadvantages in industrial capacity, resource availability, and strategic position. The Allies won not through superior individual weapons but through overwhelming numbers and sustained production. American factories alone produced over 96,000 aircraft in 1944, more than Germany manufactured during the entire war. For aviation historians and enthusiasts, the Do-335 remains an object of fascination precisely because it arrived too late. The tantalizing question of what might have happened had it entered service in 1943 instead of 1945 generates endless speculation. Could high-speed reconnaissance variants have provided better intelligence? Might fast bomber versions have disrupted Allied operations? Would interceptor models have increased bomber losses enough to affect strategic bombing campaigns? The answers remain unknowable, lost in the unrealized possibilities of history. What remains certain is the aircraft's technical achievement. Creating a fighter that could exceed 470 miles per hour using piston engines required solving countless engineering challenges. The push-pull configuration demanded precise thrust alignment to avoid control problems. The long-drive shaft powering the rear propeller had to withstand tremendous torque while remaining perfectly balanced. Cooling systems had to manage heat from engines buried within the fuselage. Landing gear had to support enormous weight during high-speed touchdowns. Every system pushed contemporary technology to its limits. The Do-335 file stands today as a monument to engineering ambition, a reminder that innovation alone cannot guarantee success. Its sleek lines and revolutionary configuration capture imaginations just as they did when Pierre Klostermann watched helplessly as one disappeared into the German skies. Visitors to the Udvar-Hazy Center stand beneath its massive bulk, contemplating the desperation that drove its creation and the fate that rendered it obsolete before it could prove its worth. The fastest piston fighter of World War II never received the opportunity to demonstrate what it might have accomplished, remaining forever a symbol of potential unfulfilled and opportunities lost to the relentless mathematics of industrial warfare.